So welcome. My name's Ken Levinson, the Executive Director of the Passive House Network, and it's my pleasure to be with you here today with Chris Magwood from RMI and talking about embodied carbon impacts, specifically single-family homes, and the study of studies, if you will, this report put out by RMI, which is really comprehensive and succinct. And so I will leave it there. I want to say a couple of words about the Passive House Network. We are a national nonprofit. If you haven't been to one of our events before, welcome. We are really focused on training and community building and peer-to-peer knowledge sharing. That this is how we see high-performance passive house, low-carbon buildings getting made. We feature our Certified Passive House Designer course. We work with EMU Passive around the tradesperson course and a host of other supporting courses, all towards, which I think is the ultimate education, is certifying your building to the Passive House standard, really learning as you're doing, working with certifiers, the North American certifiers, Circle, and getting across the finish line. We hope you join us as a member, join a chapter. We have regional chapters, and we are looking to build community across the US. We are an American-focused organization, but part of the international global Passive House, International Passive House Association, and affiliated with the Passive House Institute. A couple of brief notes on upcoming events. So really happy to have our next PHN DEI event happening on July 27th. It will feature a discussion on really a movement towards development disclosure, so that communities that are getting hit by our push and many people's push for housing in our housing shortage and sustainable housing at that, what are the impacts of these? And it should be a really interesting discussion about getting more information out there and tying into a wider array of sustainable issues and making sure that social justice, racial justice is part of the climate conversation and our sustainable conversation. The trainings, Certified Passive House Designer training, is coming up later this month in the Midwest and Rocky Mountains. We hope if you're in those regions and are interested, that you don't wait any longer and go for it. As I say these days, the climate crisis is not waiting. It is going full speed ahead, and we can't afford to wait any longer. We will then be in the fall in the Northeast and Pacific, so it's a great opportunity. It's accessible, flexible, and affordable. Again, working with EMU Passive on the Certified Tradesperson course and their boot camps, one coming up at the end of this month in Vermont. I believe it's at Yes Tomorrow in Northern Vermont, and then in Minnesota in the Minneapolis area in the fall as well. We have a conference coming up in September and October, in person in Denver, October 4th and 5th, and really pleased that Chris is going to be at the conference in Denver in a session dealing with issues around passive house, embodied carbon, and environmental sustainability, all issues dear to his efforts and ours as well. With the Passive House Conference, we've also got the Design Awards. Encourage anyone working with Passive House Standard, working in the detailing, in the optimization, great design, great energy efficiency, great carbon outcomes to submit. The deadline is September 4th, and we will be announcing the winners at the conference. And the key is really climate-specific design solutions. We have a wide range of climates here, and this is not just for American projects, but including projects in Canada, Central America, South America. Across the board, we want to see innovative solutions, beautiful solutions that are adapting and addressing the local needs. And I would be remiss not to call out, given this topic today, our tool, the PH ribbon that we've worked with the Passive House Trust, the AECB in the UK for developing, which works within the PHPP as an add-on to the PHPP, so that you can calculate whole carbon emissions, including the embodied and operational, for the life of the building. And we're excited to announce a new version is going to be coming out because the new PHPP has just come out. We had hoped to have it ready by now, but it's going to be with us momentarily, so stay tuned. I just note a quick case study that you should check out on the website under PH Ribbon Case Studies. Really fascinating use of the tool. The last thing I'd like to mention before we dive in here is the Icebox Challenge, also coordinated with the conference. It's happening right now in Fort Collins, Colorado. It will go on to Louisville, which is in Boulder County, which is in the burn area of the Marshall Fire. And the first reveal for Fort Collins will be happening this Saturday. You can still make a guess. If you haven't, go online, go onto the website, give your best guess for how much ice is left in each one. They were both loaded with approximately 2,000 pounds of ice a week and a half ago. And the conventional build was slightly more ice, so we'll be taking that into account. And will be really interesting to see what the final results are. Fort Collins now, Louisville, and then on to Denver in September. All right, let's get to the featured topic. PHN Presents is a free educational platform. We like to cover a wide range of issues that relate to Passive House, that intersect with Passive House. And embodied carbon is right up there among them. The hidden climate impact of residential construction, new report from RMI. I will just say, by way of introduction, that I've had the pleasure of knowing Chris for a number of years now. First met him through the Endeavor Center some time ago, where he's working. The Endeavor Center is a nonprofit organization, sustainable building school, working with natural materials. And really, I don't know, it felt like a laboratory as much as a training center. And really, I think seeing how far they could go and push things. He, of course, is at the Rocky Mountain Institute, RMI's Embodied Carbon initiative. He joined in 2022 with the Carbon Free Buildings team. He also established Builders for Climate Action, a really important group. Please look up if you haven't heard of them, and led the development of the Beam Carbon Estimator tool, which we'll hear a bit about. He also recently co-authored the book Building Beyond Zero, New Ideas for Carbon Smart Architecture with Bruce King. An excellent book. I encourage everyone to get a copy. Great reference material. It should be on the bookshelf behind you. All right, with that, I am going to stop sharing. Hopefully we have a good crowd now for you, Chris. And you can go ahead and share.
All right.
Everyone, I should note as we're transitioning, please put your questions into the chat, any comments into the chat. When Chris is done presenting, we'll have a conversation and we'll be pulling your questions, either that you put in during the presentation or as we're having our conversation. So we want to make sure we hear from you. Great, take it away, Chris.
Okay. All right. Well, thanks, Ken, for the intro, and thanks everybody for deciding to spend an hour of your day. If you're on the East Coast, your lunch hour, hanging out and thinking about and hearing about, and at the end, sort of discussing embodied carbon in residential construction. So, brief further introduction to myself. Ken sort of alluded to this already, but I come from a background in residential design build. I started a little over 25 years ago in Ontario, Canada. Have done a lot of work with what people would call kind of the alternative materials, things like, you know, straw bale and hempcrete and stuff like that. But had the chance to work on a lot of really great buildings, both as a builder and, as Ken alluded to, as a teacher at Endeavor Center. And before we sort of dive in, so the work that I was doing at Endeavor was really focused on being a sort of metrics-based way to you know, do sustainable building. From my very earliest sort of intros into the field, which was building my own house about 30 years ago, I quickly realized, you know, the extent to which greenwashing was kind of ubiquitous in the field. And so for my own house and for everything I've done after that, I was pretty obsessed with trying to figure out, you know, how do I measure that I'm doing something better, and then, you know, be able to do that early on in the project to sort of shape the design, and then also kind of do it during the kind of whole procurement process as we're putting the building together. Really, you know, to be able to say to the owner, to know for ourselves that, you know, we did something that was measurably better. And that, of course, you know, had to do with energy efficiency, and you know, two of the projects you can see on the screen now are passive house, you know, buildings, but also things around, you know, material toxicity, how much waste we were, you know, taking to the landfill, all of those kinds of things we were really kind of obsessed with measuring. And then in, I guess it was maybe 2011, my daughter sort of asked me one of those questions that you know, pushes you in a whole new direction. And her question was, you know, I'll paraphrase, but it was like, hey, Dad, you know, I know that you're doing the building work you're doing is, you know, it's good for the planet, and that's why you're doing it. But, you know, I'm really freaked out about climate change, and are these buildings actually good for the climate? And so, you know, that made me stop and think. And I felt like I could say to her, yes, on the operational side, you know, for quite a long time at that point, we had been, you know, making extremely energy efficient buildings, running them with renewables. We had been, you know, making fossil fuel free buildings for about a decade at that point. So, you know, I could sort of honestly say, yes, operationally, what I'm doing is good for the climate. But I had already started thinking a little bit about materials and their carbon footprint, and I honestly sort of had to shrug and say to her, I don't know about that, but I'm really interested, and I'm going to go find out. And so that really kickstarted what has now been a 10+ year, you know, jump down the rabbit hole of emissions that have to do with building materials, and sort of have resulted in a kind of career shift for me. The development, like Ken said, of the BEAM tool, writing the Build Beyond Zero book with Bruce, and then the work you're going to see in this presentation. So I am at Rocky Mountain Institute now. We have a whole embodied carbon team there doing all kinds of cool things. Today I'm going to focus on this report that we did on residential construction, and it just got released a few months ago. And I guess I'm going to start with the big headline result from that study, which is that if we kind of look at the results from the studies, and I'll sort of go more into them, but at the big scale, what we realize is that if the average embodied carbon emissions we're seeing from the materials to make new homes in the US is at all accurate, and we kind of spread that average out over all the new homes that get built in a year in the US, we're looking somewhere in the neighborhood of 55 million tons of carbon going to the atmosphere from the materials from making new buildings. And, you know, obviously, like, I punched, you know, all these numbers into my little spreadsheet, and I got this answer 55 million, and that seemed really big, but I wasn't quite sure, you know, what kind of scale that was at. So I looked to the IPCC and looked at countries, you know, from emissions from entire countries. And so emissions from materials for new homes in America are in the ballpark of emissions from entire European countries like, Austria, Greece, Hungary, Norway. So, we are dealing with an issue here that is pretty substantial. If the new home sector in the U.S. was its own country, it would be ranked somewhere in the 20s of global emitters. So, altogether, a fairly major issue that if we're in this industry, we do want to be addressing. So the report from RMI is really a study of studies. So with Builders for Climate Action, we had done 4 fairly large studies of embodied carbon in new homes. All of these are working with as-built home designs. So developers and builders were giving us plans of things they had recently built, and we were doing a full analysis of those. And you can see there's sort of 4 different regions and climate zones, including South Carolina and Florida. So we have sort of, hot and humid climates, and then some colder climates in Toronto and Nelson, and then a sort of, West Coast, slightly more moderate climate in BC. And, as we modeled out those individual homes, we found what you see here, in the red dots. In every location, there were homes that were, quite high in terms of their embodied carbon. The number you're looking at is kilograms of emissions per square meter of heated floor area. So that's what these are referring to. But what really stood out to me was that across all of these studies, over almost 800 homes we looked at here, and across all of these different regions, across all of these different sort of home styles and types, that the average was actually fell into a pretty narrow band, and that's what sort of made us feel like we could take that average and sort of estimate what emissions look like over the entire US, because so much of what we studied fell into that little narrow band there. So before I go too much further, there are some different ways that we can kind of report on emissions from buildings. And I just want to kind of familiarize you with them because there's a good chance I'm going to bounce between these things. So one way is to look at, the net emissions. So you sort of add up all emissions from all the materials of a building, and you get a total number for that building. And it's usually expressed in either kilograms of CO2e or more likely for a whole home as tons. And that number is really great for, doing things like estimating what emissions across, a region or a construction company or a city or something like that might be, or an entire country. But it's not a great way to really compare between homes, because obviously, a 1,200 square foot home and a 5,000 square foot home are going to have different net emissions just based on the size of the home. So to normalize for size, we kind of take the net emissions and divide it by the conditioned floor area, and that way we get to an emissions intensity. And that was the results I just showed you from the studies are in this intensity form. We do intensity by conditioned floor area because what we realized as we looked at especially a lot of suburban homes is that very large garages tend to have lower per square foot emissions than conditioned space. The garage is often not insulated, it's not finished, there's no interior walls. So there's a lot less net emissions. And if we just looked at gross floor area, building a giant garage actually, would make a home look like it's better from an embodied carbon point of view. So we, along with the partners in the cities that we were doing these studies for, decided to prioritize living space. And so when we do the intensity by conditioned floor area, things like unfinished basements and garages are sort of penalized because the emissions from those materials are part of the total, but we're only dividing that total by the conditioned floor area. And so rather than giving benefit to those non-living spaces, this way of looking at intensity sort of penalizes them. And then finally, we're not really looking at this in today's presentation, but it is a really interesting way to think about this. And I invite you to go to the report and kind of look at this, which is emissions intensity per bedroom, which is trying to get to a way of thinking about emissions, not by the size of the building, but by the number of people it's serving. And it's really interesting. Quite often, in the same study, if you look at a building by emissions intensity by floor area, it looks like maybe one of the best buildings in the study. If you look at it by emissions intensity per bedroom, it can be one of the worst. So if you're thinking about density, if you're thinking about emissions per person served, this can be a really good way of thinking about emissions as well. Briefly, the tool that was used to do all these studies is the tool that I helped develop at Builders for Climate Action. It's called BEAM. It's a free spreadsheet tool. It's based on environmental product declarations, and it's a spreadsheet tool that's quite simple to use. And because the same tool is used across all of these studies, the results are quite comparable between them, which is often not the case with embodied carbon studies, because different software will give you different answers. And so, we wanted to make sure we were using the same tool and the same methodology across all of them. So a few ways of kind of slicing and dicing the results from these studies. One is to look at all the materials in the studies and sort of see proportionally by material category, what really stands out. And across the Canadian homes in the study in Vancouver, Toronto, and Nelson, BC, it's interesting that the proportions are pretty similar across all of those places, with concrete kind of dominating the emissions at about a third, insulation being the next most impactful category, and the sort of percentages varying because different markets tend to have different insulation types and different insulation requirements as far as code goes. Cladding often falling next, and then interior surfaces, which is like a catch-all for flooring, wall covering, and ceiling materials. And then windows were pretty consistent across the study. And then, other stuff starts to get small to the point where it's not sort of the main things that we want to be addressing. So, one of the big takeaways from the study is, here are the things to think about if you want to address your embodied carbon. The amount of and the kind of concrete you're using, the kind of insulation you're using, the cladding that you're choosing, and the types of materials you're putting on your interior surfaces. And if you're addressing those, you're really attacking the lion's share of the emissions. As this little chart shows, there's no point really in addressing it in your roof, because the roof framing and the roofing itself is a pretty small percentage of the average building. One thing that I want to point out is that those results that I showed you, the sort of per square meter results across the studies, there's a lot of things that aren't included in that. And so they're not included because currently the data isn't particularly great, or it wasn't when we did those studies. And so, we didn't include things like mechanical, electrical, and plumbing, fixtures, appliances, finishes, all of those sorts of things. Since the studies were done, there is a bit more data out there on these things. And so you can kind of see here, I've kind of done an estimate for a sort of average 200 square meter, which is about 2,000 square foot house. And some really substantial quantities of emissions that are in finishes. In particular, paint was a bit surprising that, this model house had over 2 tons of emissions associated with the paint on the walls and the ceilings. And exterior and interior doors, added quite a bit with just over 1 ton each. Fixtures, not, in total, if you have 3 bathrooms, each with a toilet, sink, and tub, you're looking at about 1,200 kilograms or 1.2 tons. So, per fixture, it's not that big. And then the sort of best estimates that I could find for the mechanical, electrical, and plumbing stuff was surprisingly low on the embodied carbon front. So this is based on sort of quantities and types of metals in these units. So not a really great analysis. We might find that, if we were including the actual manufacturing pieces, these numbers would go up. But the biggest one here is actually wiring. Both the copper and the casing for the wiring are both high impact, and we just, there's a lot of it in terms of quantity. And then, appliances similarly, not all that big, but we are missing, somewhere in the neighborhood of about 50 kilograms of emissions per square meter. So, it's not insignificant when we add all of these things up. And obviously, as this space moves forward, these numbers will hopefully migrate into tools like Beam and pH ribbon and start to be things that are counted more regularly. So here are these same results that I showed you earlier. And what to me really stood out, I was expecting to find some things at the high end. I was expecting to find some things at the low end. I was not necessarily expecting that the averages, especially in Vancouver and Toronto, would be so close to each other. But what really stands out here is these low results, because nobody in any of these studies was trying to make a low embodied carbon house. These were buildings that had been built in the previous year or two. Embodied carbon was not on the map for any of the builders who sort of shared plans with us. And so the fact that, there are builders whose absolute business as normal kind of way of doing a home is, in Vancouver, 30% less than average, in Toronto, 40% less, and in Nelson, 50% less. To me, like that's our low-hanging fruit. That just identifies that, cost-effective, available, affordable, code compliant materials are out there and, being used, I think in these cases by happy accident, not by choice, but, that there is a way that homes can, reduce their embodied carbon from 30 to 50%, over the counter today, because, these builders happen to be doing it just by the sort of the accident of the suite of materials that they were choosing. Similarly, the builders who ended up with the highest results, they were not setting out to build a really high embodied carbon house. It's just sort of these accidents of, one builder happens to choose a lot of materials that are, at the high end in their category for embodied carbon, and another builder happens to choose materials that are at the low end. But, that low end is really encouraging to me, if we're looking at, well, we've got to reduce emissions globally by 40% by 2030. Well, there's a pathway for home builders right there. The 40% reduction option and pathway already exists, and we can see it kind of illuminated in the study. Oh, there's a rogue graphic sitting there, but this is a quick snapshot from the study we did for Vancouver, where we kind of took in red, those key material categories that were in the previous slide, and from the as-built scenario, and then we kind of looked at, well, what if we substituted that with some of the best available materials on the market today? And you can see that, yep, that got us that 40, in this case, 44% reduction, but, something in that 40% range, by choosing materials that are currently in the market and being used by builders. And then we kind of, cast our eye forward a bit, and we're like, well, what if you put in some of the best possible materials, which all of which also exist, but they're used much less frequently and may not be as widely available. But in that case, we're able to see a pathway to something pretty close to a zero embodied carbon home. And so, having done these studies, and in particular, having worked with a bunch of the developers whose plans were or contributed to the studies, I think there's a lot of appetite in the industry to start reducing embodied carbon, but also people get really overwhelmed. When I say to them, hey, 40% reduction is available to you, it's like, they're not quite sure how they're possibly going to get there. And so, one of the things that we're really working to sort of show builders now is that you don't have to tackle that 40% tomorrow. If we are trying to reduce emissions by 40% by 2030, and you start this year, really, if you start knocking 5% a year off your home plans, off your designs, you will get to something close to 40% by 2030. And so, that just makes it more of a staged and intentional effort to get there. Obviously, if you want to jump from where you are today to a lot lower, that's great too. But it could be like this year, talk to your concrete supplier and find the lowest carbon concrete that is in your market and that can work for you. Good chance that's going to actually knock off a lot more than 5%. And so that's what you need to do for this year. Maybe next year you sort of start comparing between the brands of insulation you're using, and you don't even have to change the type of insulation. You may find that just changing to the brand that has the lowest carbon footprint, there's your next 5%, etc. This isn't a prescription, and it won't be the way everybody does it, but the idea is, you can address this kind of one piece at a time and still really build towards some meaningful reductions. And if it sounds like a 5% reduction is not all that amazing, to put that in context, if every home that's being built in the U.S. reduced its embodied carbon by 5%, that would be the same as avoiding the emissions from a California wildfire. So, these incremental impacts that we can make, if we make them collectively across the whole industry, they really do add up. And if we can keep staging those 5% changes year by year, we really do get ourselves on the kind of pathway that we need to be on. Because I come from a background in building energy efficient buildings, and I know this is a passive house group, so the intersection of operational and embodied emissions is really important to all of us. And I think the one thing that I really want to stress, and if you leave this this presentation with only this piece, is that quite often the operational and embodied side are seen as like trade-offs. Like you could make one better, but it'll make the other worse, or vice versa. And what we found in the study in Nelson, BC, where we had both the energy models for every home done in the same program in Canada's Hot 2000 program, and then our embodied carbon models, what we found was there was no direct correlation between energy efficiency and embodied carbon. And I'll sort of explain this graph. British Columbia has a step code energy system. So something at step 1 is the least energy efficient, and something at step 5 is kind of Canada's equivalent to net zero ready home. So definitely not passive house level of efficiency, but high and higher than code minimum. And the steps 2, 3, and 4 are in between. And what you can see, especially at step 4, so step 4 is right now in BC, or when we did the study, is voluntary. It's like being a bit ahead of the curve, being more energy efficient than code minimum. And what you can see is that there were a lot of houses at step 4, and that the highest carbon footprint house on the embodied side and the lowest embodied carbon house in the study were both at step 4. And that over here at step 5, that wasn't a higher embodied carbon building. There's 2 of them in there. They were really, pretty much on the average. And similarly, if you look across the study, there was no direct correlation between the energy efficiency of the home and the embodied carbon. And this points to something that I think I know from my own practice, which is that we don't have to give up one to get the other. Really, we need to be paying attention to both of these, and the sort of the need to get both to zero in the next few decades is real. And so we can't go about it with the mindset of like doing one really well is going to make the other one worse. we have to sort of tackle this in a way that we're addressing both sides of that equation sort of equally and with the same level of determination. So yeah, I mean, this is just an illustration of that same notion. Like, you know, you can have a high embodied carbon house with really low operating emissions, and its total emissions are still high. And you can, you know, reduce that embodied carbon, but if you haven't addressed the operational side, it's still high. The only way to get, you know, a real whole life carbon result that's low is to you know, be working at both simultaneously. And while I don't want to, you know, put it in terms of trade-offs, because I don't think that's the right language. I think, you know, what you want to be doing is looking at these two things iteratively at the same time. Like, you know, does this move that I'm making to reduce the operating emissions, does it have a really high embodied carbon impact? If so, can I change, you know, that impact so that I can still achieve the operational goal, but not do the embodied carbon? Maybe that particular operational intervention isn't worthwhile when you look at the embodied impacts. You know, it's not, there's not going to be a single answer, in the same way that not everybody makes a passive house the same way. You know, sometimes you are going to decide that it's better to throw more insulation in the attic than to get a better window, or you're going to, you know, address it on the mechanical side, or, you know, there are many pathways. And I think when you throw the embodied carbon assessment into there, it's just another, you know, factor that you'll end up sort of balancing. And I think, you know, everybody in this space is getting pretty good at optimizing. And so, you know, the embodied carbon piece is, you know, it's not an either or, it's something that you just start working in and optimizing. Oh, my slides seem to be frozen. Let's see if that needs to go.
You're not frozen.
No, I'm not frozen, just my slides are.
Do you want to
Okay.
try on sharing and sharing them?
Yeah, I'll let's see. Okay, so I'm just about at the end of the presentation piece here. I just want to quickly share a couple of case studies that we included in the report. This one, Valley Muse by Valley Homes in Phoenix. You know, I chose this one because it's a great example of paying attention to both sides of that operational and embodied equation. You know, these are passive house designed. I'm pretty sure they're getting them certified, but I won't say that for sure. So, you know, they're really addressing operationally, they're electrified and passive house level of efficiency. And then they're also really paying attention to the materials, you know, such that their carbon footprint of, in this case, 59 kilograms per meter squared of conditioned floor area, you know, is half of even, you know, some of the best results in the studies. So, you know, they're able to far surpass what we were seeing as, you know, a good example in the studies we did. And then similarly, New Frameworks, this home also designed to, but I'm not sure about certified passive house, but again, really energy efficient. And in this case, getting the material emission side down to just over 30 kilograms per square meter. So, you know, even a smaller fraction of what is considered kind of average in the studies that we looked at. So, you know, just a couple companies, and there are many more where both sides of that equation, the embodied and the operational, are kind of being taken seriously, and really, you know, big movement being made on both sides. And yeah, just again, some more examples, some of these from my own practice, some from you know, builder colleagues up here in Ontario, but you know, all different ways of getting to, you know, either zero or very close to zero on both the operational and the embodied side. And I kind of just wanted the collection of homes put together because, or buildings put together because, you know, there isn't one sort of suite of materials or aesthetic or, you know, anything that guides a home to zero embodied carbon. It's really iterative and done on a case-by-case basis. So next steps for me and the work I'm doing at RMI on this topic. We are just setting out, the ResNet board approved just earlier this week, the development of a standard for calculating and reporting embodied carbon in new homes. So this is an attempt to make sure once the standard is done that everybody who's measuring it, we're all getting the same answers because we're all using the same methodology, because we're all relying on the same standard to get there. And so this will be an ANSI standard, and obviously useful to people who do HERS ratings, but also useful and open to anybody at all who wants to be measuring their embodied carbon in the same way. And then actually, I'll just go back and just make a quick plug here. We're assembling the technical committee to actually write this standard right now. So if there's anybody in this group, Passive House gatherings are usually pretty good for having nerds who like to dive into things. So if you're interested in being part of the that standard technical committee, you can reach out to me and let me know. And then we are also working at RMI on a voluntary home builder climate commitment program. That's a way that home builders can report on their both operating and embodied emissions, and make some public declarations about being on a pathway, and being able to sort of report on and sort of share their decarbonization pathway with their investors, with their home buyers, and with the industry. And if you're interested in diving deeper into the topic, all of the reports that this RMI report are based on are here. There is a great European benchmark study that's also included in the RMI report, so the link to that is here. The US Department of Energy through NREL did an embodied carbon model of a new home as well. So you can check out that study. And if you are sort of interested in playing around with the BEAM tool, there's the link for finding that. And so I think with that, that's the end of the presentation bit. And so Ken, if you want to do Q&A,
I'll come back
and
here.
Good to go.
Great presentation. Thank you, Chris. And as expected, a lot of good questions, detailed in general. We will try to incorporate as many questions as we can here in the time we have remaining. Chris, I didn't actually mention this bit while we were logging in. If I could, questions we don't get to, if I could clean them up, so to speak, make it easy for you to respond to. Could you send us answers back following up, and we'll post those online along with the presentation. So don't fear if we don't get to you, but we'll do what we can.
Or maybe fear, because then you'll get a very long-winded written instead of a short verbal one.
Yeah, the more the better with this. So I wanted to take one step back initially a little bit in this idea of it being a study of studies. When did this really take off? I think you talk a little bit in the report about the Carbon Leadership Forum, and and where do you see these studies going?
Yeah, I mean,
a little bit of background there.
The Canadian-US studies that we did at Builders for Climate Action, they're kind of gathered here, were done between sort of 2020 and 2022, so they're all quite recent. And they were, I think, really interesting because they I had done some studies prior to that that were kind of like models, right? I made some model buildings. The Canadian federal government gave me a bunch of model buildings, and that's interesting, but you don't know if that's reflecting what's going on in the real world. And what's great about all the studies that are summarized here is they are based on home plans that were built within the last couple of years, and analyzed in the same way. So that and kind of not fully random, but a call just went out to builders who wanted to participate. So, it wasn't self-selected, high performers or anybody like that. It was just the cities that we were doing the reports for were, asking builders if they wanted to share plans, and anybody that said yes, we were kind of looking at them. So, when I saw how close the averages were, that to me that was really interesting, especially that the southeastern U.S. houses, which are very different in their construction style, they're CMU concrete houses. They have very different amounts of insulation and stuff like that. But in the end, like the whole building had, on average about the same carbon footprint as, a house made in a northern climate, in Canada. And so, it made me feel like, yeah, like there is a band there that a lot of homes fall in, regardless of their climate zone, and that we could see high and low options in all of those climate zones too. So the thing that made me feel best at the end of the study was like, okay, like there is a path forward here for anybody. It's not like, oh, poor me, like I'm up north, I can't address my embodied carbon, or I'm in a hurricane area and I have to build with concrete, so I can't address my embodied carbon. It's like, nope, there are people in all of those zones, doing things that make a really big difference. So that was great to see. And I think where these studies are going, I think we'll see more of them. I know the Northeast HERS group is trying to get together a benchmarking study for homes in the Northeast. Yeah, I would love to see more of that kind of stuff done. Like what homes in Texas look like.
Right. So with these studies coming on and more of it, and getting our arms around it, just another big picture question in terms. It's great to see this the ResNet work coming on, and this pooling this sort of declaration of achievement, and hopefully we can celebrate a bunch of projects and really put it out there. Like in New York, we have the Buildings of Excellence program to bring in the embodied carbon and do that. I'm curious, I know there has been some movement around affecting code, around affecting regulation, and where you see the intersection of these activities with that at this point, and what we might expect going forward.
Well, I think one thing with the studies, so that the one that the Vancouver study and the Toronto study were commissioned by those cities because they wanted to find out like what's a reasonable threshold, and they are both now doing voluntary programs, but programs to say like, okay, like here's the embodied carbon line in the sand. In Vancouver right now, they're actually giving people money for building homes that come in under that.
They're incentivizing it.
Yeah, in Toronto, if you want to, it's not direct, they're not directly incentivizing embodied carbon, but embodied carbon is now part of the Toronto Green Standard. So if you want to get any of the incentives that you get for meeting the Toronto Green Standard, you have to be below an embodied carbon threshold. So I think that's to some degree where this stuff is going, is that the sort of the cities that care, and there are a bunch of across the US too, can do a study like this and go, okay, like with some decent certainty, we know that here's a line, and we can, to start with, incentivize people to get better than that, but eventually they're going to require it.
And we see, I think in Boston as well, pushing carbon emissions requirements of this type. And I'm curious where you're seeing, is the industry, how is industry reacting to it? Are you seeing pushback in the way you do against every energy efficiency step is it's a trench warfare, so to speak?
I mean, to some degree, yes, but I've been really surprised on the embodied carbon front. I thought maybe the larger home builders would be, hesitant, or, more than hesitant about joining on. But what's interesting is, especially the sort of the publicly traded ones, they all have to start making ESG reports now, and those ESG reports include your scope 3 emissions, which for a home builder is your embodied carbon. And having to measure it is something that they're all starting to realize they're going to have to do.
Mm.
And so they actually are very supportive of this ResNet work to come up with a standard for doing that measurement. But as more and more of the investments into those companies are going to hinge on their ESG report, and particularly their climate performance.
So the production builders in particular, they're looking at every penny of extra cost. So in regards to metrics, how do we see is there a calculation of cost per ton of CO2 saved, and what's the low-hanging fruit?
I mean, there's definitely the low-hanging fruit of talking to your concrete supplier and getting a lower carbon concrete mix. There's very rarely any cost premium for that, and because concrete is around a third of the emissions of most homes, that in itself, like that one phone call to the concrete supplier who can say to you, yeah, actually I do mix with this carbon footprint per cubic meter or whatever, you can knock 10-15%, sometimes even 20% off the carbon footprint of a building with that one phone call, and it often costs
with such a substantial focus on concrete, is the concrete industry responding?
Absolutely, yeah. Like if in terms of embodied carbon data, there are like 25,000 concrete EPDs, and then if you turn to like a category like insulation, there's like 20.
Right, but if I'm Joe Builder making that phone call, what are the chances that the concrete supplier is going to be like, yeah, we can do that? Or
yeah, it's getting better and better all the time. Like the sort of the whole concrete industry has really started to pivot in the last 4 or 5 years from like not wanting to engage on the topic to really pushing on the transparency side, pushing on having EPDs, pushing on like making these mixes available. So I can't say that everybody's going to get a positive response when they make that call, but I know I do up here, and I know lots of builders can and do, and the number of batching plants that are aware of what makes a higher low carbon footprint mix and how to do it is going up. And
that's
so
great.
I think, yeah,
that's great. I mean, and that's so important in terms of viability, affordability.
Yeah.
And so I'm going to ask you the question that all passive house people hate being asked, because it's about optimization and it's complicated and there's so many things going on. What do we see in terms of the affordability for doing, on the low end of the embodied carbon? Do you see an average cost increase? Have you been collecting that data? I know in past
no, not. I mean,
come by.
any information that I have on that is from my own practice, because it's so hard to gather that, right? Like, everybody wants the cost info, but are we talking cost info in Nelson, British Columbia, or downtown Toronto, Ontario, or somewhere in South Carolina? Like, those costs aren't the same across all those places.
Well, let me put it this way: did you it's apparent that the contractors in particular and the architects who are specifying, if there are architects involved, I mean, single family homes, the majority of them have nothing to do with architects.
Yeah.
Or the vast majority.
Yeah.
It seems like they have a lot of choices in terms of levers to pull to reduce the embodied carbon emissions. Do you see patterns of use? Are they going for like the big three?
Yeah. I mean, I think that's really, when we were designing the beam tool, the whole point of that tool was to make those comparisons really easy. So like, if you go to the insulation section in beam and you say, I need to cover 2,000 square feet at R20, you will see the carbon footprint of every insulation that we have listed in the tool side by side. And that in itself has been, huge. We've had so many people tell us like, I didn't know, but now that I've seen that, like, and the costing information, builders know what things cost by and large, maybe some of the alternatives, not so much, but if you're scanning down a list and you're seeing, uh, fiberglass bat insulation, mineral wool bat insulation, cellulose insulation, like you have a pretty good sense of what that's going to cost you. And you can look at the carbon footprint number and, it doesn't, I think builders can do that mental math pretty quickly of like, oh yeah, this is something in the range that I could, it's either cheaper than or the same.
Have you looked at, you talked about excluding mechanical systems and a whole sort of laundry list of things. I can't recall if you did or not, but have you looked at PV panels or batteries?
Yeah, that one is tricky. Yes, you can look at PV panels, but I'm hesitant to attach the embodied carbon of a PV panel to the carbon footprint of the building if I'm not attaching any of the grid embodied carbon to another house. You know what I mean? Like it's I mean, yes, it's part of the house because you bolt it to the roof, but I feel like it drifts the scope of the study in a way that isn't really fair. Like,
well, that brings it to another, like, you can kind of go bigger picture too, is like, what about the infrastructure to these houses, right? And if a house is built closer to existing infrastructure or further away, or what the type of development is, if it's a multifamily versus all detached single family homes.
Yeah.
Is there any sense to look at those kind of multipliers of carbon?
I think there's a lot of sense. I think you won't find clear answers. Like we can't parse that right now the way that we can materials, in the categories that end up in a tool like Beam. We could parse it for PV panels, but like I said, it's like, how come then we're attaching the power generation embodied carbon, to a house with PV on the roof, but we're not attaching any embodied carbon for the entire grid that's behind, another house. Like I don't quite know how to make that an apples to apples, because it's not just, well, you've got PV, so you should bear the responsibility of this embodied carbon, but you don't, so yours should look a lot lower. It's like it's not that easy.
So I wanted to make sure we touch base for a moment or two on the whole idea of the natural materials, the wood construction, the going negative. You show a huge potential there. It was very much in looking at those initial studies in the markets. These show the EU with a huge negative number that we should be jealous of. And so how does that fit into kind of the evolution of this thinking? The Beam, as I understand it, the Beam is not covering wood materials.
The full range of wood materials is in Beam. Currently, Beam doesn't attribute carbon storage to the volume of carbon atoms in a wood material. I think the next version coming out in the fall, we're going to change so you can actually toggle that on or off. But there's a pretty big and unanswered question around the actual climate value of carbon stored in timber in buildings. That doesn't, our current ways of doing life cycle assessment don't really tell you whether this is good for the climate. It's really just, there are X number of carbon atoms in this 2x4. And it's like, well, that's great, but did putting those carbon atoms in my building make the balance of carbon in the atmosphere lower or higher? And we don't really have a way of answering that. And I think the uncertainties are big enough that I don't think we should be saying that all wood storage is valuable. I mean, bottom line, on average, less than half the tree makes it from the forest into your house. If the other half that did make it into your house has gone back to the atmosphere, it's been burned as fuel or rotted out in the forest as slash, something like that. The atmosphere carbon balance is exactly the same, and the tree that you took down is no longer being a carbon sink. So you've removed an ongoing carbon sink, you put half of the carbon atoms in the building and half in the atmosphere. Are we better off? I don't know.
Right.
And
so, well, if I might, just to combine with that, then the idea of fire-wise construction. We don't want these wood buildings to burn down in wildfires. Horrific on many levels.
A wood frame building, clad with the right materials and insulated with the right materials is very unlikely to burn down. So, I think that the fire side is really, really important to think about. And, again, that's one of those trade-offs. Lots of folks in Nelson were like, most of the claddings that you're calling low carbon aren't fire smart. And it's like, so that you don't have the lowest embodied carbon cladding on your building. That's okay. Do better on your flooring or your, drywall or your, there are many other places where you can sort of make that up. It's not like you have to choose the lowest embodied carbon material in every category. Passive house people are aware of that. Like it's a balance.
Absolutely. The optimization, right? And and I think that really goes hand in hand. I think maybe to end on the note of, buildings are super complicated. Embodied carbon is a key aspect of this, and to acknowledge that. But if you speak a little bit, I guess my last question here, and then we'll send on the rest to you, is, there I see maybe it's not a split attitude, but there is we can change the spec and lower the embodied carbon and address climate in that way, or and I know it's not an and or choice, look at the design integration, and how are you seeing teams being most successful in terms of, presumably, I don't want to, looking at it holistically in terms of design integration. What tips would you maybe give folks who are thinking about
I think spec wise, you're right. Like, and if you want to find the no cost, super easy, low hanging fruit, right now there are surprising differences between, competing products. You're not even changing products. Like, you look at all the drywall options that are out there, there's somebody making drywall with like 40% less emissions than their competitor. So like those kinds of things, the low carbon concrete mix, an insulation brand that has the lowest carbon, a drywall brand, those sorts of things, that's, as long as that company is in your market, those are really easy changes to make. They're usually cost neutral. They don't affect anything on site, people install them the same way. So like there's that level of intervention. Then there's kind of I'm going to change the material type, but it doesn't really affect my design, right? Like I'm going to put in a different kind of back insulation entirely. I'm going to use a different continuous insulation. I'm going to use a different flooring, but it's like all of those pieces still go in the same place and in the same order. And then there's like, I'm going to change my design. Like I'm going to do like the wooden slabless slab, or I'm going to, not do a basement, but I'm going to do one more story above grade, or, like those sort of larger interventions that take more time and more thought to do. And there's gains to be made, in the embodied carbon performance in all of those ways. You could do them all and add them up, and that's how you get to those like, hey, I dropped my embodied carbon by 80%, but it took all of those pathways. But you can be finding 20, 30, 40% down any one of them.
Great. This is wonderful. I have a number of questions, both from the audience and myself, in terms of going on, but we could go on all afternoon. So we're going to leave it there.
Okay,
and
I'm just going to give you a heads up that I'm actually leaving for vacation in a few hours. So I won't be answering the questions immediately, but I will get to it when I get back. So
we'll be patient. No problem. At your convenience. And with that, I want to thank you for your time today, Chris. Thank everyone here. Is it possible to share the presentation in a PDF?
Yep.
Great. So we'll post that along with the video, and eventually the answers.
Okay.
I hope everybody can join us at the conference, either remotely or in person, certainly in person if you can in Denver, with Chris, myself, and a whole bunch of others. Super important work across the board. Thank you all for being here, and have a great day.
Yep, thanks everyone.